In this video, we are going to go over the bit string flicking, which is a topic that appears in the American Computer Science League Junior Division Contest 2. So here on my right side of the screen is a Quizlet set that I have created. If you're in my competitive programming team, you have this link sent to you in chat, so please use this before you do the contest. If you're other people watching this video, I will put the link down in the description below, so feel free to use it. Okay, so let's start with some implications first. Bit string flicking in the ACSL only has binary numbers. That means the only digits that will ever appear are 0 and 1. So you don't have to worry about 2, 3, 4, 5, all that stuff. It's never going to come out. 0 in this case represents false, 1 represents true. You do not have to understand this to understand the functions that I'm about to explain later on in the video. It's just, if you want to dive deeper into this topic, just know that 0 is false, 1 is true. If you consider that fact while listening to the rest of the lecture, you will see that everything falls together. But again, you don't have to know the false and true. You just have to know that only 0 and 1 will appear. Okay, so let's get right into the functions. First function is not. The ACSL is going to give you not in terms of not some kind of number. The Quizlet says opposite 0 becomes 1, 1 becomes 0. This is one of the most straightforward functions. It's literally the definition I wrote. Let's say we have a random number 1, 1, 0, 1, 1. The answer is going to be 0, 0, 1, 0, 0 because you switch each digit. If it's a 1, it becomes 0. If it's a 0, it becomes a 1. Very easy, very straightforward. Let's move on. And is another function. The competition is going to give you two numbers this time, some kind of number and some kind of number. What the AND function does is, I said multiply each digit, but the actual definition is both have to be true in order for the output to be true. But like I said previously, you don't need to understand that. Just the shortcut, multiply each digit. Let's say we have two numbers, 0, 1, 1, 1, 1, and I don't know, 1, 0, 0, 1, 0. What we're gonna do here, let's put these two numbers like this, up and down, just because it's easier to look at it this way. If you prefer vertical, that's totally fine. Just multiply the digits. What we're gonna get is 0, 0, 0, 1, 0. So that's the answer here. Just use the shortcut. It's much easier and much faster. Okay, or is kind of similar to AND, question mark or question mark. So it's gonna give you some kind of number or some kind of number. So again, let's have the same example, 0, 1, 1, 1, 1 or 1, 0, 0, 1, 0. This time, let's look at the definition. If at least 1 is 1, then it's 1, otherwise 0. That's kind of a tongue twister, but essentially the same thing as AND. We're comparing each digit by the corresponding digit. So let's do the same thing, 0, 1, 1, 1, 1, 1, 0, 0, 1, 0. First digit is at least one of these two, 1. Yes, so the output is 1. Same thing here, at least 1 is 1, so the output's 1. Same thing here, same thing here. The fact that both of them are 1 doesn't change anything, it's just 1. Again, 1 here. This was actually a bad example. If we have two digits, 0 and 0, that's gonna be 0, okay? Because none of them are 1. So just keep that in mind. XOR. That's a very interesting function. The Quizlet says if different 1, if same 0. That's pretty straightforward. Let's use the exact same example: 0 1 1 1 1 XOR 1 0 0 1 0. 0 1 1 sorry 1 1 1 0 0 1 0. Let's compare each digit. First one, they are different. If different, we output 1. They are different, we output 1. They are different, we output 1. They're the same, so we output 0. These two are different, we output 1. So basically 0 1 and 1 0, if you have to compare these two, that will yield 1 because they are different. If they're the same, which are the cases of 0, 0, 1, 1, they will yield 0. Very straightforward. We will continue with the functions. Shift is essentially you push the numbers, digits. This is a very informal definition that I came up with because of the way that shift functions work. So let's look at L shift first. L shift is going to come in the form of L shift dash or hyphen some kind of number and then the binary number here. Let's create an example. L shift 2, we see this one here, so let's just use this one, 1 1 1 0 1. Okay, here's the steps. 1 1 1 0 1. We create seats for each of the digits, or spots for each of the digits. The definition says push to the left by n and replace empty spots with 0. What this means is I'm going to take this number, I'm going to shift to the left by 2 in this case. 1 2. Notice how these two are out of their seats. We're going to delete them and replace empty spots with 0. So that is the answer to L shift 2, 1 1 1 0 1. R shift is essentially the same thing, but you do it to the right. So R shift 2, let's do the same thing, 1 1 1 0 1. Let's create 5 spaces, 1 1 1 0 1, and we're going to push this number to the right by 2, 1 and 2. Notice how these two are out of their seats. Delete them, 0 0, and that is the answer to R shift 2, 1 1 1 0 1. Okay, let's look at two other functions, L-circ and R-circ. So circ stands for circulate, and you'll see why it's circulate. So for L-circ, I wrote the definition as take n digits from the beginning and move them to the end, so left to right. That's the shortcut, but let me show you the steps first. Let's use this same number just to avoid any confusion. L-circ 2, we have 1 1 1 0 1. Okay, so first what we're gonna do is shift by 2. 1 2 3 4 5, 1 1 1 0 1. Let's do the same thing as L shift 2. We have 1 and 2. This time we are not going to delete these two for being out of their seats. Instead, we're going to move these two to the end. So in L shift, these two are supposed to be 0. In L-circ, these two are replaced by the ones that are outside of their seats. And now you see why I said take n digits from the left and move them to the right, because 1 1 1 0 1, and if I take the 1 1 and move it to the right, that's the same thing. What I did was I took 2 digits from the left, CIRC left, and moved it to the right. That's CIRC. CIRC is the same thing, but you move it in the opposite way, from the right to the left. CIRC 2 11101. Okay, again, let's say we have 1 2 3 4 5 spots, 11101. We're going to push this right by 2, same thing as R shift, 1 2, right? But we're going to use these 2 digits and replace the empty spots. This is the same thing as taking 11101, taking 2 digits from the right and moving it to the left. 2 digits from the end and moving it to the beginning. 2 digits from the right and move to the beginning. Here's another important thing to consider. When you're solving ACSL problems, you will see that all of these functions are mixed with each other, and you will not know what order to proceed in. So for instance, in math, there's PEMDAS, right? PEMDAS, parentheses, exponents, multiplication, division, addition, subtractions. Well, in bit string flicking, there's PNSCAXO. This doesn't, like, we can't pronounce this, but anyways, parentheses first, then not, then shift, then circulate, then and, then XOR, then OR. This is like the PEMDAS of bit string flicking, so make sure you know this. Okay, so with that in mind, let's move on to example problems. Here's example problem 1. If you haven't solved it yet, please pause the video and attempt to solve it. Otherwise, we'll start. I hope I copied this down correctly. According to the order, I need to do what's inside the parentheses first. Inside the parentheses, there's an OR and an XOR. I should do XOR before OR, so we need to take care of this part first. 01101 XOR 01111. Let's remind ourselves what was XOR. XOR is if 2 digits are the same, we get a 0. If 2 digits are different, we get a 1. Okay, with that in mind, 0 and 0 are same, we get a 0. 1 and 1 are same, we get 0. Same, 0. 0 and 1 are different, so we get a 1. And 1 and 1 are same, we get a 0. Okay, let's improve our handwriting there. Okay, so what I'm gonna do is take advantage of the OneNote, the program that I have. We're supposed to solve this on paper, but I know. We're going to replace this with the answer that we just got. Again, inside the parentheses, 01011 or 00010. Let's solve that. We know what OR is. If at least one of the 2 digits is a 1, then it outputs 1. Both are 0, 0. At least one is 1. Okay, 1. Both are 0. We get a 0. Both are 1. So that's a 1 because at least 1 is 1. At least 1 is 1 in the last digit as well. So 01011. So let's delete this and replace with this. Not 01011. That is very straightforward. 10100. 10100. We get the answer of E. Okay, so let's move on to problem number 2. If we scroll up here, that is problem number 2. If you haven't attempted it yet, again, same thing, please pause the video and attempt it. Otherwise, we will start. So, according to our order, we should start with anything inside the parentheses. We'll start from here. CIRC 1 10100. So we will copy down 10100, and remember that CIRC 1 is you take the left digit and move it to the right. You take the beginning digit, move it to the end. We're gonna delete this, replace it with the answer that we just got, and then the next parentheses. CIRC 2 10011. We take the 2 digits from the right, move it to the left, and there we go. We will delete this and move this one in place. Okay, now we have 01001 and 11100. Remember the shortcut for AND, just multiply the digits. If we go ahead and do that, we get 01000. So then that's our answer, which will give us D as the correct answer. Okay, problem number 3. We start with what's inside the parentheses again. So if we have L circulate, left circulate to 01100. By this point, we just know that 01100. We take the 2 digits from the left and move it to the right. Okay, we will replace this part with our output. Okay, another set of parentheses. Right shift 1, 01100. We have 01100. Let's make 5 spaces. Okay, if we push this to the right, we see that this 0 goes out of place and this is blank, so we replace it with a 0. So we can replace this function with the answer. Okay, so then just to decrease confusion, we'll get rid of the parentheses now. According to the order of precedence, we must do not first. What we get is 00101, obviously. We can replace this part, and takes precedence over or. So if we take this part, 10001 and 00101, just remember the shortcut to multiply. Sorry for the voice crack. 001. Sorry, 001. Okay. We can replace this entire part with 00001. Remember, for OR, if at least one of the digits is a 1, then the output is a 1. So our final answer is 00111, which will give us C as the correct answer. And on to the last problem, number 7 here. ACSL problems are not usually this long. This problem is intended for entertainment and challenge purposes only. So let's solve it. Okay, this is the full, extremely long, absurd problem listed out here. I'm not going to read the whole thing, but immediately we see that there are 2 parentheses here. So this is where we should start. Ultimately, this region and this region are the same level, since they are like the second parentheses inside a parenthesis. So we'll start with this region here. L shift to 111110. So 6 ones and 1 0. 1 2 3 4 5 6 0. Okay. Without actually simulating the push, this time what we're gonna do is we immediately know that these 2 ones are gonna move out of spot, because if we push this to the left by 2, and there are going to be 2 empty spots at the right. So we just put 2 zeros there. Okay. Again, if you're unsure of any of these, sorry for the voice crack, you should perform the push simulation by yourself, because I did it quickly just for the speed of this video, but anyways. So if we move on to this region here, we know that not takes precedence, so we will solve this one first. Not 0001001 is 1110110. We will replace this. Okay. So if we copy and paste, XOR, what it does, like I previously mentioned, is if 2 digits are same, it will return 0. Different, it will return 1. So we will copy this number down as well, 1110110. These two are the same, so they're all the same, which means it's a 0000000. That's a very interesting number. So what we can see from here is if we have AND, we're multiplying the two digits. So again, this is 7 zeros. 1, 2, 3, 4, 5, 6, 7. Okay. Now another set of parentheses here. R circ 3 1001 001 1001 001. We take the right three digits, move it to the left. That's our value here. Okay, let's delete the parentheses. Delete the parentheses here as well. I shouldn't have deleted that. Okay, so let's move this part and start solving from the left here. But we do know that not will always take precedence. So 1 1 and then 5 zeros. 0 0 0 0 0. Do we see any more knots? I think we do not. So from here, XOR or AND XOR XOR, we know that AND will be the first one that we have to solve. So we will solve this region, 0 0 1 0 0 1 0 and this one. So if we multiply each digit, what we're gonna get is 0 0 0, and then they're all zeros. So how many digits are left? 4. Again, we get 7 zeros. 7 zeros. That's pretty insane. Then we know that XOR takes precedence over OR, but we always start from the left, so we get this part. Are they the same? No, so they're gonna get a 1. Is this and this same? Yes, that's a 0. Third digit, they are the same again, that's a 0. Fourth digit, they are the same, that's 0. Fifth digit, different, that's 1. Sixth digit, same, that's 0. Seventh digit, same, that's 0. Okay, we can delete this part. And if we can delete this part, get this number to replace. Again here. Before we do the OR, we have to do the XOR. So we take this part here. That's obviously all the same. So we're going to get a 0 0 0 7 zeros anyways. We can delete this as well, because that's going to give us 7 zeros. XOR again. Now what we do is compare. 0 and 1 are different, we get 1. 0 and 1 are different, we get 1. 0 and 0 are same, we get 0. 0 and 0 are same, we get 0. That's different, we get 1. That's same, we get 0. That's different, we get 1. Okay, now on to the last step of this long problem. 1 0 0 0 1 0 0 or 1 1 0 0 1 0 1. Okay, at least one has to be 1 in order to output 1 for OR. So our answer is 1 1 0 0 1 0 1. Do we have that answer there? 1 1 0 0 1 0 1. So D will be our answer. Alright, so that concludes the video for today, a video about bit string flicking in the ACSL Junior Division. I hope you found this video helpful. If you did, make sure to smash that like button, subscribe, comment for more content, and see you next video.